Okay, good morning. My name is Marco Guadalupi from Satellite. I'm going to talk about, again, IoT from our point of view, and the relation with Earth observation maybe is not, as my Thomas said before, no? It's different. It's a different approach. Maybe it's a new revenue stream. We don't know. But okay, let's see how we can add some idea. Here we'll see the approach from the standard point of view, from the 5G point of view. So let's see how we can help. First of all, who we are. Satellite is a 5G NB-IoT NTN Release 17 coverage extension satellite operator. We work in SSO low Earth orbit, and we are a wholesale service operator. We offer our service to mobile operator, not to end user. Okay, so we are not working on a specific application. We extend the coverage of mobile operator, and we'll see what mobile operator can do with this kind of extension. In case of Earth observation, maybe we are not going to see Vodafone working in space. So our idea is a bit different. So we are totally agnostic to scalable network architecture. So we'll see how we can do that. Our approach is to work with a small satellite, theoretically form factor CubeSat, and with some constraint in terms of antenna, in terms of power amplifier. Here we'll see the reference number of the protocol. Into this protocol, there are different kinds of scenarios, GEO, LEO, MEO. Okay, exists a scenario called Set4, where we said, okay, guys, let's work with the small satellite that will help to have a more cost-effective solution. Okay, so the approach of Satellite is looking always to a cost-effective solution. Then we enhance the solution into the CGPP with some new concept called store and forward, but maybe it doesn't make sense now if we are talking about real-time tasking of satellite and so on. But it's an approach that allows us to reduce the cost of the solution. We are member of the 3GPP since 2019. That's a key point because 5G is a terrestrial network, as you know. It's a terrestrial protocol. And thanks to ESA and the satellite community, we push to adapt the 5G protocol also to non-terrestrial network, in our case, to LEO satellite. The idea, basically, we have some active on that is connected to ground tower using 5G IoT protocol, and you lose the coverage. So you look for another operator. It's roaming, basically. It's a roaming approach. You are in Spain, you move to France, you are flying in an airplane, or basically you lose the coverage. Maybe there is coverage from a satellite. This is a direct to satellite access. There is zero equipment cost for the final customer, zero investment for the mobile operator because this is a roaming. We are a mobile operator, basically. So as it happened on the ground, we are just plugging our core network with the mobile operator core network, and we have a seamless roaming between all these GPP operators. It's scalable business model because we rely on mobile operator to sell the service. So in each country, we have a partner that is the mobile operator, and they sell the service to application providers. That's vertical implementation. Smart agriculture, livestock, wildlife, wildfire, why not, and any kind of IoT application where they are specialized on that application, and we extend the coverage through the satellite. This feature is our first satellite. Of course, it's not the final one satellite. It's a concept satellite for IoT from space, but it's not the final one because power capacity is not enough for this implementation. During the standard, during the definition of the standard, many companies applied to study item. Satellite was the first space company number of contribution. That's very important. Here you can see many chip vendor, many mobile operator, many RF module vendor, many space company, many IoT device vendor, many phone vendors. Okay, so it's CGPP is a collaborative environment where everybody can suggest solution. If they make sense for the community, we can bring to the standard. Okay, so we have here many players from many assets. Airbus is here, for example. Thales is here, for example, but also Qualcomm, also MediaTek, also Oppo, Xiaomi, and so on. Okay, Huawei, Nokia, Ericsson, all these big guys, plus some small guy like Satellite, contribute to this standard. Now let's see the approach. CGPP is in charge of many aspects of the protocol. That's what our colleague Frank said before. No? Many challenges are already solved into the standard. So why we want to invent again the wheel? QoS is solved. Broadcasting, multicasting, authentication, security, all these aspects are already solved. 5G NTN is an adaptation to space, but all these challenges are already solved on the ground network. So here we have just an example of how many working group is a nightmare sometimes to work here. It's a real nightmare. We invest many hours a week, not a month, not a year, a week. Maybe full day talking with the 3GPP leader and the 3GPP partners to solve ephemeridis. Ephemeridis? What does it mean, ephemeridis? Almanac, what does it mean, almanac? Once we said almanac, oh, this was a problem. Until now was ephemeridis. Now you said almanac. So start again talking about almanac. It's a bit a nightmare. It takes a lot more time than proprietary solution, yes, for sure. But you go further, thanks to the standard, okay? So Release 17 is the starting point. We'll see later. CGPP is a big organization, guys. It's a very big organization, okay? All the standard organizations are part of the CGPP. The ecosystem is very big. We have individual members. We have market representation partners. We have industry members. In the last few years, many industrial vertical companies applied to CGPP. And that's very important because if you are not there, you are not in position to explain your use case. So Earth observation satellite operators are not here. Only telecom operators here. If Earth observation satellite operators are here, they can explain their needs. They can explain their use case. The organization is based on use cases. If you don't have a use case, don't lose your time. You need a use case to bring to the standard use case, so the standard can be adapted to the use case to take into account also that vertical. Okay, so that's the beauty of this organization. 5G, everybody knows. We have many use cases. In terms of generic name is broadband, IoT, and ultra-reliable network. Satellite is working on the IoT aspect. Okay, here we have seen I need tasking the satellite, I need to download the telemetry, and I need to download data. Different aspects, different use case. If you need to download data, look to the code enhancement, mobile broadband. If you need to download telemetry, IoT maybe is feasible, maybe it's enough. If you need to task the satellite, maybe IoT is enough. The approach is different because the implementation is very, very, very different. An IoT device can be half duplex. If you work in NB-IoT, our approach is NB-IoT because we believe that massive IoT require very low-cost devices in terms of hardware, in terms of spectrum, in terms of power. NB-IoT is the more efficient IoT protocol into the 5G ecosystem. And here we see, for example, a half duplex devices. 3.5 kHz uplink. It's very cost effective. But you need more capacity and still telemetry and telecontrol. Maybe you need LTM, NTN. Is another IoT protocol below the 5G ecosystem. So 5G is very powerful, and the adaptation of 5G to NTN cover all these aspects. Cover the enhanced broadband and cover the IoT. Okay, so if you are going to think under your study for Earth observation IoT, IoT means a low throughput protocol in this workshop, okay? But if you need to download data, things to 5G NTN, like new radio, like broadband, okay? Because the standard is there. The standard is there. So think about this standard as an option for these use cases. That's the start of the protocol. In 22, the release 17, June 22, the release 17 was closed. It's finalized. It's a reality. And now we are working on release 17, 18, and 19 to improve capability on the NTN. Spectrum. That's another important point. Frank always talks about spectrum. And here we was talking about spectrum yesterday and tomorrow also. At the moment, the standard includes these two spectrum. Why? Because the community that was there proposed some spectrum for their use cases, the availability, the ITU definition, the availability, and so on, and these two bands are there. But if you have more use cases, if you have more needs, if you believe that new spectrum is needed, or that other spectrum is feasible for that application, we can bring to the 3GPP. Talk with us, talk with other partners, talk with Airbus, talk with other players into the 3GPP, and the new spectrum can be moved to the 3GPP. It's feasible. The first chipset announced a few weeks ago. That's feasible. That's real. Now he's working on, this is a Quectel, one of the leaders of chipset in 5G and 4G, BG95 and BG77. This is a low power one chipset. It's available, it's feasible. It's for devices. Now he's working on Geo. soon will work on Leo, I hope. Probably is there, the standard is there. You avoid lock-in. You can buy Quectel, but soon you can buy any other. They are part of the GPP. You can buy chip, you can buy module, you can buy chip from MediaTek, you can buy chip from Qualcomm. New announcement arrived in the last week. So the market is moving. So no lock-in, interoperability. If you work with this kind of protocol, you can connect to Satellite, but you can connect it to other operators. But in a seamless way, it's roaming. You don't need to do any special adaptation, no configuration on the fly, anything on that. It's totally standard. It's very, very open. So investment protection, value for money, very, very cost effective. Because it's half duplex. This is the first mobile phone. Bullet build mobile phone for Caterpillar and Motorola. This mobile phone includes an NB-IoT chipset from MediaTek. They announced 3 weeks ago. Quickest, simplest way for our customers, carrier for channel partners to sell the service. Yes, because it's seamless. It's exactly like a roaming. 5G smartphone, non-terrestrial network, pushed by MediaTek. Okay, so the standard gives these options. They move quickly. We didn't done anything for them. We work into the standard. In a day, they appear and say, we have the chipset. The chipset is feasible. Now let's see in Leo and let's test, because of course you have to be certified by us also, like any chipset you put into the market. If they change the firmware, your new mobile phone has to be tested by every mobile operator following specific procedures. There are organizations in charge of the certification. You don't have to do anything. They do because this is the industry. So CGPP is an industrial, well-adopted, massive standard in terms of standardization. So that's our approach. Yeah, this is the architecture, the reference architecture in Satellite. Bit different because here there is no mobile operator, because this is for Earth observation use case. So if we have a third-party mission control software that needed to talk with a satellite, we can onboard into the satellite an NB-IoT device. We are not doing special adaptation or broadband and so on. Our satellite support NB-IoT standard interface. So maybe we can onboard into the satellite this small device with a SIM card, and the other side, we can deliver this information to the mission control center instead of delivering to a mobile operator. Okay? If you want to work with Vodafone, we can also work with Vodafone. And so we can extend the service of Vodafone also in LEO orbit. Okay? So totally compliant. Our approach, because this is a startup, this is a European startup, it's not America, was to modify the protocol, the 5G protocol, in some interesting way, looking what's happening to the industry of the Earth observation. And that's the concept of store and forward we bring to 3GPP. When you turn on your mobile phone, this mobile phone is connected to a tower, where is the base station. The base station is always on connected to the core net, always on. If you cut the fiber, the base station stops the emission and your smartphone is disconnected. What happens in IoT? Typically, a cow is not connected continuously to YouTube, right? Or a plant is not sending messages all the time, right? Because you have to control the battery. So you have these continuous messages on the ground, and you want continuous coverage in space. Doesn't make sense. So what we said, okay, we will envision a discontinuous coverage in space. And so if you do that, now we have coverage, now you don't have coverage, now you have coverage. So you have to synchronize the device with the satellite. That's good, because in this way, we'll reduce the density of satellite in space. It's a low density constellation. That's a good approach to reduce the cost of the constellation. But what happened? Then we need many ground stations on the ground, because we need to connect the base station to the satellite with the core network. Because if we cut the fiber, we lose the base station, right? And that's not good, because if it's not feasible to have a ground station on the ground, you don't have service. So we bring to the 3GP a new concept, that's the store and forward. The store and forward allows us to have a low density ground station network. We don't need so many ground stations every time we have visibility over a target area. So we store messaging, we store procedures, and then we forward procedures to the ground and close the loop. And this is possible also with roaming. Without roaming, it's quite easy. But when you have roaming and you have to talk with an external operator without continuous connection, it's not so easy. So there, we developed this system. These interfaces are internal to us, and now we are bringing to the standard to standardize the behavior. So we can tell to device, to the Earth observation satellite, for example, guy, I'm not real time. I'm storing forward, but if you want to beacon something, I can catch and then forward. That's an approach, for example. We'll see in the future what will happen. But this system allows to work one satellite, start to offer the service, grow the network, grow the constellation, increase the density of ground network, increase the density of satellite when the market asks for this development. At the beginning, you can reduce the cost of the approach of the market. These are typical ground stations. Space, KSAT, commercial available. We don't need a specific ground station. What we can offer to this project, to this workshop, we have a testbed, full end-to-end testbed, where we can test the idea. If you have ideas, we can test this idea. This testbed is in Barcelona, it's located in Barcelona. The Polytechnic of Catalonia is a physical testbed on the ground, of course. This is compatible with dynamic satellite tasking, why not? And real-time distribution information, of course, because it's there, is on the ground. There is no satellite flying. But we can also offer the firmware, because this is, the standard is open, but you have to code, okay? We coded the base station, the E-Node-B, and we coded also the firmware. So if you want to do some kind of test, this testbed is available. And very soon, in some week, we hope that Falcon 9 transporter will fly from California. And this satellite, Satellio 0, will be available also in space to do the first end-to-end NB-IoT full compliant with the standard, okay? And so this satellite will allow to do this kind of test also, again, some other asset flying in LEO orbit. And yesterday, thinking about this workshop, this is a potential terminal you can onboard your satellites. It's flight proven, you have heritage, the firmware can run into this SDR. The implementation of this service in space in some satellite to do a test is feasible in just few weeks of integration. These devices come from, I think, GOM Space and Allen Space. The firmware come from us, can work into this kind of zinc. So it's quite easy to have a flight proven device for your Earth observation satellite. Okay. If you want to talk about the lean budget, we published a paper during the International Aeronautical Congress. There you can see many details about the lean budget, but basically you will see that the terminal is a standard one, 23 dBm. That's the power emission into the CGPP for standard terminal devices, and then you can read more detail on the lean budget. So that's the approach. Okay, that's our satellite. We are connecting here Spy. We are connecting Capella satellite, but of course we can also connect big ESA satellite. Maybe it doesn't make sense to talk about cheap approach, because this big satellite has many subsystems costing a lot of money. But for this other satellite on the left, of course, onboard device like SDR is very cost effective, and the 3GPP NB-IoT or the new radio 5G protocol will be is available from partners. Today we have developed, for example, but in the market we'll see soon more partners developing this adaptation of the standard. And be careful about the band. Okay, that's an important point. The band is a key point in any kind of this application, also to offer service on the ground and also to offer service to Earth observation. The suggestion from Thomas is very, very interesting. You can merge this concept with 5G, with LoRa, and onboard the processing into Earth observation satellite will bring this kind of use case very, very, very quickly to the ecosystem. And at the end of 23, this is an example of this continuous coverage constellation with 4 satellites in phase 90 degrees in the same orbital plane. That's an example of what kind of coverage we can offer around the world. Over the ground, we have 1 message per day minimum all around the world. That's useful for some kind of use case. In San Francisco, around 3 messages per day, for example. So maybe we can test with the Earth observation satellite also, if you want. And if we move to bigger constellation, okay, here we have some KPI to understand what's happened with this kind of discontinuous coverage. Again, it's not for real tasking of a satellite. It doesn't make sense. If you need to real-time task a satellite, this constellation is not feasible for you, but can be useful for any other kind of delay-tolerant tasking or delay-tolerant telemetry download. And in the future, because store and forward is compatible with pass-through, when the constellation will grow, maybe with inter-satellite or more ground station, we can see better improvement. With 64 satellites, for example, we have an end-to-end latency less than 1 hour. That make a lot of sense. And that's it, guys. Thanks to listen this story about standards and our nightmare every day about standard, but it's the fight we choose to play, and that's it. Any question?
What about the inter-satellite link? Are you covering also this use case on the 3G?
Yeah.
And how, in our, let's say, business case, our business use case scenario, is this implemented?
Okay, basically in this architecture, you see that in the middle there is a store and forward, but this onboard network function can be adapted to the scenarios. If I add, for example, IDRS from add value inter-satellite link direct to GEO because it's easier. So to have inter-satellite link into LEO is not so easy. I mean, I need more satellite, too much satellite at the moment. Okay, so the onboard capacity choose which is the routing way. So we can go through a GEO satellite, or we can go to the ground station when we have visibility to the ground station. So this functionality is totally transparent. The E node B doesn't take care about what's happened below. There is a backhaul, store and forward backhaul, or real-time backhaul. The E node B doesn't know that. Okay, so it's perfectly transparent. So if you have, we can deliver telecom and telecontrol, the control plane or the user plane in real time.
What you're saying is the GEO doesn't need to be a 5G.
No.
Different type of
Yes. Because here we open the protocol. Here is 5G, NB-IoT, and then here we have IP network, for example, will be fantastic. That's the backhauling. And then over that, we have the control plane and the user plane following 5G. Okay? But it's transparent for the transport.
Thank you.
Any other? Oh, Frank.
Now, in your example, you put a standard UE, so a narrowband IoT module. That is a Quectel of €1. You put on a
€3
satellite. Then I would assume still, in particular, if we talk then LEO to LEO, so not LEO to GEO, we would still need some adaptations for the air interface in terms of maybe additional Doppler compensation and so on. So that would need that somebody, let's say a group of people, would need to go to 3GPP and put this as an additional use case, also with all the effort behind it.
Yes, maybe.
I see. That would be something for release 19 or so, if there's enough momentum.
Can be analyzed, because if the concept is compensating the Doppler, and it is a matter of parameterizing the Doppler compensation, it's already in the standard. You don't need to do any other task, because it's already covered. If you said, no, let's compensate the Doppler without using GNSS position of the user terminal. In that case, it's an improvement. That's in release 19, for example. So maybe it's already covered by release 17. It's not needed to do any kind of new feature into the standard. Have to be analyzed. Okay?
Yeah.
It's just configuring the algorithm into the device. So it's delegated to the device vendor when adapt the implementation.
I see, but there will be limits.
There will be limits. Yes, have to be analyzed to see exactly if it's already covered or some concept can be improved. Okay? But there is room of dialogue.
On the slide that you show with the link, where you show the link budgets, what is the data rate?
It's a few kilobits per second. It's more oriented to messages. It's like the edge cell in a ground station, on the ground. It's like NB-IoT on the ground, but the edge of the cell. Okay, it's still inside the standard, and it's around a few kilobits per second.
Thank you.
With our satellite. Our approach is a wide beam, one antenna wide beam. Okay. evolution will be some